Hi guys, and welcome to today's video on Perpetuities, continuing a further maths course for you, and hopefully you're enjoying it. If you haven't already watched the previous videos on this financial mathematics series, then please go back and have a look. They are all on MaffsGuru.com and on my YouTube channel. Now, it is really good to see you here. Thank you so much for dropping by. If you haven't already done so, and you are new, can you do me a favor? And over in the corner, there is a red arrow pointing to a doohickey that effectively subscribes to my YouTube channel. Believe it or not, this is a fairly interesting setup that there's just me doing these videos. Now, I love doing them, and hopefully you are learning from them, or will learn from this whole series to cover all of the courses over here in Australia and the world. But you subscribing is greatly appreciated to me. Far out! Okay, here we go. Perpetuities. What on earth is a perpetuity? Well, in the previous video, we looked at annuities, and I quoted the idea that the Australian pension scheme was an annuity where we put loads of money in, and when we retire, the bank effectively pays us out. And they keep paying us, and they give us little bits of interest, but the more we take, the less the interest, and eventually the money runs out. So, for our financial calculator, we're effectively looking for our future value to be zero. So what on earth is a perpetuity? Well, actually, a perpetuity is very much like my pension I have in the United Kingdom. I've paid a load of money in, I get interest on that money, and the good thing is that when I get to retirement age, it pays out the same amount every single month, and it never runs out. Well, until I sadly die. But hopefully that's not going to be for many years to come. So perpetuities never ever run out. The money we put in and we invest stays there, and what we're really doing is we're living off the interest. Now that's actually quite important. Okay, so a perpetuity, we're living off the interest. Now, if we see from what I'm going to hope to do for this lesson, basically know what a perpetuity is, understand the language of perpetuities, use our CAS to help us solve. And this is a CAS-enabled course, which is great because our CAS has financial calculator stuff on it that'll do all this hard work for me. Know what V0 is, the rate of interest, and a regular payment. Now, this regular payment is effectively the money we're going to take out. Now, we've built on the idea of reducing balance loans and interest-only loans, and now annuities, and then we're going to deal with this. So, as I say, what is a perpetuity? Well, hopefully, that's what I studied it. It is basically, it's a bank account. The money you put in, and the money that stays in that account is constant. It doesn't change. Your future value and your present value is exactly the same. The only thing you're going to do is live on the interest. And so I said, Barry, we're at it again, Barry, with this language. So like we've done in previous video, let's look at the language you're using. Now, V0, and sadly, a lot of maths confuses people because of the language. So if you're allowed to have a summary book, for example, this is the stuff you put in your summary book. The calculations or the formulas, make sure you know which one to use and when, and hopefully none of this is going to be particularly complicated. So V0, that's the amount we're investing, the initial amount in our perpetuity. And as it turns out, our final amount in our perpetuity. Every bank account we ever go to, hopefully is going to give us interest, right? That's the whole point of loaning the bank our money, so that they can sort of use it for whatever they use it to, but give us a little bit of a thank you for us depositing with them. And that thank you is called interest. And this value of D is basically the money you're going to get each month or each year, depending on when the perpetuity pays out. And that's the important thing. Interest rates are given per annum, but generally speaking, perpetuities will work out per month. And so we need to make sure that when we're given this R, that we turn our rate of interest into a monthly interest rate. Generally speaking, when we're doing pencil and paper working out. If you're going to use the calculator, and I'm going to show you how to use the calculator, that's brilliant. It's done, don't worry about it. It does all the hard work for you. So let's have a look at some examples, because theoretically speaking, if we know the formula as we have here, it's D, which is our regular payment. Our interest payment is given by the rate of interest divided by 100 times V0. Bang it in your summary book, and life goes on. So Elizabeth is investing her superannuation payment or payout of $500,000. Sounds a lot, doesn't it? Sadly, not really. Into a perpetuity that will provide a monthly income. There you go. That was the hint. Monthly income without using any of the initial investment. What that means is she's not going to use any of her principal. So like that annuity, we kept taking some of our money away from the principal. Not in this case. If the interest rate for the perpetuity is 6% per annum, thank you very much, what monthly payment will Elizabeth receive? Let's do it first way, the formula. So we know that D was equal to R on 100 times by V0, yeah, which was $500,000. Still sounds a lot, doesn't it? Now we have to be very careful here because remember, our R that they gave us was 6% per annum. But I need to make sure that my money is given monthly. So to turn an interest rate into monthly, I do 6% divided by 12 per month. And that will give me an interest rate of 0.5% per month. So that's the value I'm actually going to put into this formula. So D is equal to 0.5 divided by 100 times 500. 1, 2, 3. How am I going to do that? Well, load up my calculator, thank you very much, because I can't do that in my head. What I'm going to do is clear my calculator. Good trick here, everyone, if you're wanting to know how to clear your calculator, just hit that edit, clear all. It'll say, are you sure? And I go, yes, of course I'm sure. It's like my car sat nav. When I switch it off, it goes, are you sure? Yeah, pretty sure. I just told you to switch it off. Why would I lie? Anyway, so 0.5 divided by 100 gives me, times 500, 1, 2, 3, gives me $2,500 per month. So there we go. So $2,500 per month. That will go forever. Assuming the bank stays at, 6% per annum, then she can have $2,500 per month until, well, forever really. And so the CAS. Now, obviously, it's a bit weird because I've just used the CAS to do that, yeah? But what I'm talking about now is the financial solver. So I'm going to bring up my calculator. If you remember from my financial solver, I need to go into that specific mode. So I'm going to go menu, I'm going to go across, I'm going to go financial, and it's already given me a load of stuff there. Now, that was from a previous example. So, N, the number of payments. Well, because this is happening over and over again, I'm just going to put 1, very much like the annuity. My interest rate was 6% per annum. Remember, my calculator does all the hard work for me. Principal value is minus 500, 1, 2, 3. Remember, it's minus because we've given the bank that money. Sadly, I'm feeling fairly negative. I'd rather have $500,000 in my pocket, but the bank are going to look after it for me. Payment is what we're trying to find. Future value stays at 500,000 because a perpetuity, we never use any of that. Payments per year 12, compound per interest, compounds per year 12 as well. Now, interestingly, remember the question didn't actually say there 12, did it? No, it didn't. So you would assume, they're generally going to trick you if not. And I hit my PMT button and up came $2,500. Thank you very much, CAS calculator. You are a gun. Example 2. So how much money will need to be invested in a perpetuity account? Thank you very much, question, for telling me perpetuity. We like that. Earning interest of 4.2% per annum. Yep, we're going to write 4.2% down per annum. That might be important. Compounding monthly. Okay, useful to know for my CAS, for my financial solver. $200 will be withdrawn each month. Because it's a perpetuity, we now know that this is effectively the interest. Thank you. Write your answer to the nearest dollar. Right, well, let's just go straight for the CAS. Seems to be fairly simple. Loading up my CAS. We're already in my financial solver. Right. Number of payments. It's a perpetuity. We make that 1. Interest rate, 4.2. Thank you very much. Principal value, we don't know it because we're trying to find it. Obviously, the question says how much will be invested. Payment, yep, we want 200, so it's minus 200. Future value, well, we don't know because it's the same as the principal value. Payments per year, 12, yeah. And compounding monthly, yeah. All right, 12 and 12. That's fine, thank you very much. What I now do is hit my principal value. And what do you notice at the bottom of the screen? Yep, at the bottom of the thing, it says 1 or more required fields needed to calculate this value and are not filled in. The problem with the financial solver is you've got to be able to have only 1 blank field. And because we don't know the principal, we don't know the future value for a perpetuity. And so the financial solver is no good to me. Oh my God, panic. No, don't panic. It's fine because we've got the formula. Remember, if all else fails, go back and use the basic formula. So we know that our payment per month is equal to R on 100 times V0. Or in fact, I should have said payment per month. I was giving you a bit of a hint there. Our payment is R divided by 100 times V0. Now, bearing in mind our interest rate is per annum, but they are going to withdraw $200 each month. We need to make sure our interest rate is per month. How do we do that? Well, my R value is now going to be 4.2 divided by 12. And so again, firing up my CAS calculator and changing it into my main mode, I'm going to do 4.2 divided by 12 gives me 0.35. So my rate of interest is 0.35%. So I now know that D, which is the money I'm going to take out, my interest, which is 200, is equal to my rate of 0.35 divided by 100 times V0. We don't know what V0 is, but we now have a way to be able to work it out. Thank you very much, CAS calculator. So I can use my solve function, I can use all sorts of different things, but what I'm going to do is I'm going to times both sides by 100, and that's going to give me 20,000. Yep, so 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros is equal to 0.35 times V0, and then I'm going to do 20, 1, 2, 3, divided by 0.35, because if I have a times, I can move it to the other side by dividing, which gives me my value of V0. Again, I can't work that out in my head, so what I'm going to do is 20, 1, 2, 3, divided by 0.35 gives me the staggering value of 500. So we know my V0 is $57,142.86. End of question, moving on. But no, because the question said to the nearest dollar. So we have to make sure that we then round that to the nearest dollar, which gives me $143. So let's write that a little bit better, so when you print it out on your notes, it makes sense. $57,143. Whoa, don't be tricked. And finally, example number 3, and I've already said in red, do you see the trick? A university mathematics faculty has $300,000 to invest. No, $30,000 to invest. All right, so my principal value is going to be 30,000. My final value is going to be 30,000. Thank you very much. And it wants to award an annual mathematics prize of 1,500. Okay, so that's my payment. With the interest earned from investing this money in a perpetuity. Thank you very much for telling me perpetuity. The exam's trying to help me out here to use the right function on my calculator. What is the minimum interest rate allowed that will allow this prize to be awarded indefinitely? And that's what the whole point of a perpetuity is. Okie dokie. So do I have all of the information I need? Hopefully. So let's fire up my CAS calculator and see. Well, N is 1. Thank you very much, CAS calculator. What was my interest rate? Don't know. We're trying to find it out. Payment, my present value, 30. Oh, don't forget the minus. Minus is important, 30,000. Yep. Payment we know is going to be 1,500. Future value, 30,000. And 12 and 12, yes? No. 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 And that was where the trick was. The word that was so important in this question was the word annual. Okay? Now, if it's annual, there's only going to be one payment per year. And there's only going to be one compounding period per year. Now, they didn't specifically say in this question that interest would only be compounded once. If they don't say it, then try and make it match the payments per year. All right, this is the best information that I can give you. And so when I press my I, what comes out? 5%. And thank you very much. There is my minimum interest at 5%. Actually, this is the end. Please don't stop. Now, obviously, exams and SACs and all sorts of different things out there, courseworks are going to try and trick you. They're going to use those small, tiny words to throw you. Always make sure you are sure by using a highlighter or whatever method you want to underline to look for those keywords. And in this situation, in that last question, the keyword was annual. Perpetuities. That's it, ladies and gentlemen. The money that we put in and the money that we have out is exactly the same. We're only living on the interest. Thank you so much for watching. Hopefully you've enjoyed the video. If you have, over there is a little doohickey for you to click and subscribe, and it would be good. I'm trying to get to 1,000 if you could get 2 of your friends to do the same. Otherwise, the video is loading below it. That is also for further maths. Have an awesome day. I look forward to seeing you next time. This is MaffsGuru signing out. Bye-bye.